We left off with standard equation of a circle. The format was up there. We talked about R standing for radius, of course. H and K representing the center of the circle. And we looked at that first example. We filled in the center and the radius. And we just cleaned it up a little bit. That would be the typical way you would leave it. You don't multiply that with the squares. So, are you making progress on B?
Yeah.
Okay. What do we know? What can we identify here?
H and K is 0.
Okay, H and K are going to be 0. And R is
5.
5. Okay. Now, I'm going to write it out an initial way, but this is not at all how I would leave it. If we just fill it in as is, x minus h squared, what'd you put?
X minus 0.
X minus 0 quantity squared plus y minus k is going to be
Y minus 0.
y minus 0 squared equals
5 over 5, 2, yeah.
5 squared.
Sure.
Now, what's this look like cleaned up?
X minus, parentheses, X minus 0.
X squared plus y squared plus 25.
X squared plus y squared equals 25 because you need to, I mean, what is x minus 0?
0.
X minus 0, you take away 0, you're at x, okay? So you don't need to write that. So x squared plus y squared equals 25. And, okay, this is the math teacher. This is the math teacher, the math course in me. But something, you know, I see an x squared plus y squared equals a number. I know it's going to be a circle. Okay, that is typical equation of a circle. And when I see x squared plus y squared equals 25, I know, okay, it's a circle, centered at 0, 0, radius 5. Okay, and that's an easy thing to acknowledge. Kind of like, I know it's first time of the year, but when I say y equals x squared, what do your brains automatically think?
Square root.
No.
No.
What's the graph of y equal x squared look like?
The parabola.
Oh.
The parabola, yes? Sorry, I didn't ask it in all the words, but y equals x squared is a parabola. Like, that's something that you just know at this level. I think you do, at least. You just need that beginning of the year reminder. Fair enough?
Yeah.
Okay. I have confidence you guys all know that. So this is a good thing to just know. Okay. When we start second semester and we go into trig, we spend a chapter doing parabolas, ellipses, hyperbolas. Okay. That's when we start looking at equations more like this. So, okay. Another example. Look at an inequality for a moment. Okay. You're asked to write this as an inequality. And it talks about the distance between x and negative 3 is less than 9. Okay? Ideas of how we could write this. They ask us to write an inequality. So like an equation, but with an inequality sign. And my hint would be to think about distance. And if you flip over to the front side of your notes, we talked about distance yesterday.
Oh.
We had a couple distance formulas. Which one applies right here?
The one that's like on the line.
Yeah. It's just the distance between two numeric values. It's not ordered pairs. So how do we do the distance between just two numeric values?
Absolute value.
Absolute value, right? So if we're doing the distance between x and negative 3, how can I express that?
Yeah.
Yeah, I think so.
X minus 3.
X minus
The absolute.
Negative 3.
negative 3. And it's the absolute value of that. Because to do the distance between two things, you are subtracting them. Okay. Is less than 9. What are we going to do here?
The alligator.
The alligator? Less than 9. Did I do the right alligator?
Oh, no.
Yes.
Okay.
Has his mouth wide open.
Now, the one cleanup I would do, what do we know about minus -3?
X plus B.
And this isn't because it's absolute value, that's just because that's what it is. So the absolute value of x plus 3 is less than 9. Okay, that's a good way to write it. So it's just looking at the words, being able to put it in symbols. Are we okay with that now that I've explained it?
Yeah.
Yeah.
Maybe you didn't get there on your own, but okay. Because you've got a couple in a section like this. Okay. We got a couple big examples left, and then we'll get you guys to homework. First example. I should have put these on separate pages. I still could.
Wow, are they big problems?
They take up space. You know how hard it is for me to write up here, but
That's true.
okay. First example. Use the Pythagorean theorem and the distance formula to show that the points -3, 4, 1, 0, and 5, 4 determine a right triangle.
Are we gonna have to do distance formula on each of the thingies, and then whatever number we get for the distance, plug into Pythagorean theorem?
Oh,
Oh
good.
my.
Now, okay, so distance formula for each of the thingies. In Emily's word, what does she mean by thingies?
The parentheses.
Coordinate point.
Yeah, basically, those 3 points supposedly form a triangle, right? So we need to find the distance of each side, and then we need to do Pythagorean theorem. So yeah, it kind of takes some space. Now, my recommendation, not that you have to, I'm a visual person, at least when I'm teaching. Okay, I'm just going to sketch a picture just so I have a visual of what I'm looking at. Do you have to sketch a picture? No, but I'm going to. It's a sketch. It's nothing official. Okay, so there's my sketch. As I said, nothing official. In all honesty,
That's a good sketch, low-key. That's an Oscar right there.
that's pretty good for me.
Yeah.
Okay. Now,
It's an Oscar winner.
in all honesty, you don't have to have the sketch to do this problem. You're just finding the lengths of each of the sides, right? You've got 3 points, so you've got to alternate the pairs. But I just, Okay. Let's pick a pair of coordinates. Which 2 coordinates you want to do first?
-3, 4, and 1, 0, something next to each other.
Sounds good. Okay, -3, 4, and 1, 0.
Oh,
Now, this is the distance between ordered pairs, so we're using the square root.
yeah.
Square root of x minus x. I'm going to say -3 minus 1, quantity squared, plus y minus y, 4 minus 0, quantity squared. Do some cleanup. -3 minus 1 is -4, quantity squared. 4 minus 0 is 4, quantity squared. -4 squared is 16. 4 squared is 16. 16 and 16 is 32. Now, there is indeed a decimal answer for it. I also am seeing the path ahead. I'm going to leave this as the square root of 32. It's going to be easier with when we have to use this number in a moment. Fair enough?
Mhm.
Okay. Pick another pair.
1, 0, and 5, 4.
1, 0, and 5, 4. The square root of x minus x. And it doesn't matter which order you do this in, right? So x minus x. So I'm going to say 5 minus 1, quantity squared, plus y minus y, 4 minus 0, quantity squared. So square root of 4 squared plus 4 squared. Math seems familiar. 16 and 16 is square root of 32. They're not all going to be that. Okay. And your other two, yes?
Yeah.
We could shortcut this one, but no one said anything, so I'll just do it the normal way. X minus x. I'm going to say 5 minus negative 3, quantity squared, plus 4 minus 4, quantity squared. So 5 minus negative 3 is 8, so 8 squared plus 0 squared, or what'd you say?
Never mind.
Square root of 64, which is 8. And I say if you caught a shortcut, these two are a horizontal line if you caught that. If your graph, and this is, you could have just counted the distance between them. Fair, it doesn't matter. Now, we use the distance formula here. Okay. Now, we need to use the Pythagorean theorem. How's the Pythagorean theorem going to help here? What is the Pythagorean theorem?
A squared plus B squared plus C squared.
Okay, good. A squared plus B squared equals C squared. Where A and B are my two legs. They meet at the right angle. If this is a right triangle, C is the hypotenuse. What do we know about the legs versus the hypotenuse? The two legs are the shorter pieces. C, the hypotenuse, is the longer piece. So fill them in, because the idea is to show that it's a right triangle. We just want to show that it makes the Pythagorean theorem true. So what are my shorter sides?
The square root of 32.
The square root of 32 is right. So we're going to say the square root of 32 squared plus the square root of 32 squared. And the question is, does it equal 8 squared? What do you know about the square root of 32 squared? It's 32, right? When you square a square root, you get whatever's under the radical, right? So I don't even have to use the calculator. The square root and the square cancel each other out. So we have 32 plus 32 equals 8 squared is 64. What do we know about 32 plus 32?
That's 64.
What did we just show?
That's the right triangle.
It's a right triangle. 64 equals 64. It's a right triangle. So this right here is proof it is a right triangle. Okay? If that came up unequals, then either A, it's not a right triangle, or B, we made a mistake. Which way did it say this? It says to show the points and determine a right triangle. That makes it sound like it's a right triangle. So if it didn't come up a right triangle, I would question myself of where did I make a mistake. Okay?
So like if we're going into it and we see 32 and 32, like we can kind of assume no, it's going to be a right triangle, right? Because the sides are the same. Or is that not valid?
No, because if the third side ends up being the same, it's an equilateral triangle.
Yeah, that's true.
I'm trying to think. I don't think two equal sides. No, that doesn't automatically mean it's a right triangle.
Okay.
Because they could be at other angles, I think. I'm trying to process it on the
Yeah,
spot, but I think so. Okay. So you have a homework problem like this in homework somewhere.
No.
Okay?
That's all.
There might be two parts. There might be an A and a B. I don't remember. There's just one. Now, next one. This focused on using your
Ooh, sneak off.
distance formulas. Now we're going to talk midpoint formulas. Hello. Yeah, I have one more example and then I'll send them your way. Thanks, bye. You hang with me for this?
Yeah.
She just said sometimes, so.
Oh, it's Mr. Bernard.
Actually, it was Mrs. Myers that called, but yeah.
Oh.
Same office, so. Okay. Use the fact that the diagonals of a parallelogram bisect each other to determine whether the points, and this is the catch about this one, A comma B, A plus C comma B, 0, 0, and C comma 0 make a parallelogram.
Yes or no?
Okay. It's not that bad. Give it a chance. Now, first of all, parallelogram. Can we visualize a parallelogram, generally speaking?
Yeah. Not really. Oh,
Four sides, right?
Yeah.
Usually when we think of parallelogram, I think of it as like a rectangle that is crooked, not sideways, right? Okay. Now, diagonals, what are diagonals of like a rectangle, a square, a parallelogram? The diagonals go from
Corner to corner.
opposite corner to opposite corner, right? Okay, so the idea here, I'm going to actually draw that one out here in a moment. That's kind of the idea of what I think of with parallelogram. Diagonals are those two pieces, yes? What does it mean? We're trying to use the fact that the diagonals of a parallelogram bisect each other. What's bisect mean? They cut in half, right? So the rule is the diagonals bisect each other. That means those two places, they're cutting each other in half. What is this of the diagonals?
The mid. Oh, was that right? Midpoint?
Midpoint.
Hey.
And what I was starting to say when the phone rang, we used our distance formula. Guess what? Now we've got to talk
Midpoint.
midpoint formula. Okay? Because we're just trying to show that if the midpoint's the same, then the diagonals bisect each other. Now, we need a sketch because we've got to know which pieces are opposite each other, yes?
Yeah.
So we need a sketch here. Okay, so let's graph some of these points. You got 0, 0?
Yeah.
There's 0, 0. Okay. I'm picking easy ones to get us started. C comma 0. What would C comma 0 do? No. C 0. C is going to take me over C, up or down 0. So C 0 is going to be some point on the x-axis. Okay. What else do we have? We have A comma B, and we have A plus C comma B. Now, B is going to be your height, right? Because we're going to have to go over A up B, and we're going to have to go over A plus C up B. Now, keep in mind, okay, so we're going to go up B, over A up B, over A plus C up B. A plus C has to be bigger than A. So I'm going to make A comma B, and this is just, I'm randomly picking, a point right here. Because it's right A, which again is a random value I picked, up B. A plus C, comma B. Write A plus C as the distance of A plus C. Well, how big is A? A is this distance, yes? How big is C? That distance. So what does A plus C look like? It's going to be, if here is C, it's going to be A past C. Does that make sense? Like if that's A and that's C, it's going to kind of be like about there. So this is the point A plus C, comma B. And we have something that kind of looks like a parallelogram. Now, what was the point of me drawing the sketch? You need to know what diagonals go with what, right? So, okay, we're trying to prove now that the diagonals bisect each other. So we want to know that these two diagonals have the same midpoint. Let's look at this one. Okay. We try and find this first midpoint. What am I finding the midpoint between? 0, 0, and a plus c comma b. So let's find the midpoint of 0, 0 and a plus c comma b. How do we do midpoint? It's on the front.
Parenthesis x2, x2 plus x1 or x1 plus x2
Either way.
divided by 2.
Mhm.
And then comma parenthesis y1 or 2 plus y1 or 2 divided by 2.
Basically, you add the x's, divide by 2. You add the y's, divide by 2. Okay? So in this case, if I do that, I'm going to say, let's see, I'm going to say 0 plus, what's my other x? A plus c divided by 2, comma, and then it's 0 plus b divided by 2. Clean that up. 0 plus a plus c is a plus c over 2. We're going to leave it like that. 0 plus b is b over 2. Okay. It's not pretty looking, but that's all right. As long as the other one's not pretty looking, we're all good. Okay, there's one midpoint. Now, we're going to find the other midpoint. This time, we're finding the midpoint between what? We're finding the midpoint between a comma b and c comma 0. So the other diagonal. Okay, so x plus x divided by 2. A plus c divided by 2. Y plus y divided by 2. B plus 0 divided by 2. A plus c divided by 2 is a plus c divided by 2. B plus 0 divided by 2 is b divided by 2. What just happened?
Same day.
They match. Okay, so now we can say that the midpoints are equal, so the diagonals bisect. And I ran out of room, but so midpoints are equal, so diagonals bisect. And that was just a fancy use of the midpoint formula. Previous problem was fancy use of the distance formula. How can we use it? Okay? You have some work done. Still not as much as I thought it'd be. We can't talk at the beginning. Okay, page 17. 2 through 18, evens. 24 through 28, evens. 38 to 52, evens. I have an obsession with evens, but it's better than saying 2 through 18, all. 24 through 28, all. 38 to 52, all. So, enjoy your evens.
Thank you.
Hey.